All right, last time we talked about inscribed angles. Now we're going to talk about inscribed polygons. And an inscribed polygon are polygons in which all of its vertices lie on a circle. On this side over here, we have an inscribed triangle, and over here we have an inscribed quadrilateral. And the circles are called circumscribed circles. So if we're dealing with a circumscribed circle, then we know we have an inscribed polygon in the circle. So we're going to talk about specifically triangles right now. And if we have a right triangle inscribed in a circle, then the hypotenuse is the diameter of the circle. And conversely, if we have, let's fix that. Conversely, if we have a triangle inscribed, which includes a diameter, then it has to be a right triangle. And it does not matter where the triangle is drawn, where the other two sides are. If one of them is diameter and it's inscribed, then we've created a right triangle. And the diameter is always going to be the hypotenuse. So since this is the hypotenuse, the right angle is always opposite the hypotenuse. And this makes sense because we know in a circle that the diameter is the longest segment possible inside of a circle. All right. So here we have an inscribed quadrilateral. Now, not every quadrilateral can be inscribed in a circle because, as you recall from a minute or two ago, to be inscribed, all its vertices have to be on the circle. So for a quadrilateral to be true, let's do yellow. The opposite angles are supplementary. So the measure of angle D plus the measure of angle F equal 180 degrees, and the measure of angle E plus the measure of angle G also have to equal 180 degrees. So our parallelograms would not qualify because the opposite angles are congruent unless it's a square. A square would qualify, but other types of quadrilaterals would not. So mostly we have irregular ones, or we have a square. So let's take a look at example of what we're going to have. Let's draw a quadrilateral. so. And let's call it ABCD. Let's do pink. So we're going to solve for X and Y. And here we're going to have 68 degrees, and here we're going to have 82 degrees. So to solve, X plus 82 degrees equals 180. So X equals 98, and Y plus 68 degrees equals 180. So Y is going to equal 112. Let's do another one with a little more involved. All right, get our circle going. Get our quadrilateral. Actually, let's make that a little better line. There we go. Let's name it RSTU. Let's find for C. This is 8x, 10x, and this one's going to be 2c minus 6. So solving it is exactly the same process. We just got to use a little more algebra. So c plus 2c minus 6 equals 180 degrees. 3c, let's do it this way. I'm going to add 6 to both sides and combine like terms. So that cancels, so we have 186 equals 3c. And let's get a little more space. So C equals 62 degrees. So come back up here. We know C equals 62. So angle R equals 62 degrees, the measure of angle R. And the measure of angle T will be 62 times 2, which is 124 minus 6, or 118 degrees. 62 plus 118 equals 180. And let's solve for U and S. Well, this is real easy because we have 8x plus 10x equals 180. 18x equals 180. X equals 10. So the measure of angle U equals 80. Oop. Oh, 80. That was right the first time. And the measure of angle S equals 100. And we